2025 Session 2 on Natural Language Processing to be delivered by Mr. Sylvester Daniel G., Head, Applied AI Center of Excellence, Mindtree. Now, I would like to introduce our resource person for the session. Mr. Sylvester Daniel, Head, Applied AI Center of Excellence, Mindtree, has over 18 years of IT industry experience spanning across artificial intelligence, big data, cloud solutioning, consulting, and application development. He has led a team of data scientists and research engineers on AI solutioning and product development. He has driven multiple AI programs from idea to implementation, covering biomedical data extraction, AI-based search solution, OCR-based text edition, facial data analysis and data extraction, image-based SKU identification. He is AWS Certified Solution Architect Associate and Hortonworks Certified Spark Developer. He has worked on many platforms and tools, to name a few: object character recognition, object detection, image segmentation, image classification, facial recognition, Python, JavaScript, CV18, text generation and summarization, and many more. We welcome you, sir. We are glad that you accepted our invitation to be the resource person for ATAL FDP.
Thank you, ma'am.
Over to you, sir. Please kindly take over the session.
Thank you. Hello, everyone. Thanks for taking your time to join this session. I hope I'll make best use of all of your time. I hope my screen is visible.
Yes, sir, it's visible.
Thank you. Okay. About me, I think already we had a brief introduction. To briefly state what I do, I focus on artificial intelligence, primarily NLP and vision-related problem statements. I lead a team of research engineers focusing on latest industrial trends, researching latest stuff that are out there, and then ensuring our customers are able to build great products through AI. So on Mindtree, I work for Mindtree. I head the COE. So Mindtree has a revenue of over 1 billion in just 20 years. We have over 21,000 employees, and obviously we are a limited group of companies which has over 20 billion revenue. Moving on to the practice that I'm part of, it's data intelligence practice, where there are over 3,000 plus professionals. We have over 120 plus clients. Primarily, we focus on part of practice. We primarily focus on accelerators, frameworks that can enable us to execute projects faster. Part of that, I focus on AI, and I'll share some of my experience, how you could build NLP applications faster and what is happening in the industry. And then I can take some questions towards the end. Okay, so with that, the overall agenda for this session is I will introduce what is NLP, maybe with some few examples. And then before I deep dive into what are the things you could do in NLP, I want to briefly talk about models. I hope some of you or most of you would have attended earlier sessions. Models generally mean the AI brain piece, which takes care of solving this whole thing. So I will briefly talk about how machine learning models, NLP models have evolved. And then what you need to focus on given the change in the industry, given the change in model evolution. I'll talk about how you can annotate better, faster, and then I'll talk about how the change in models have enabled us to develop all these NLP tasks faster with fine-tuning concept. And then I will spend some time explaining what are the different NLP tasks that you could do, and then how part of COE, what is our solutioning preference? If you are given a NLP problem statement, how do you solve, how we suggest you solve the problem? I will briefly talk about it. And then finally, MLOps, which is very, very important piece, which the industry is adopting aggressively. And that's really interesting piece, which I'll cover towards the end. Uh, Getting into what is NLP. NLP stands for Natural Language Processing, obviously, and it's a branch of AI which enable its computer to interpret and understand how humans speak and make sense out of it. To give you an example, if I make a statement, I like Apple, most of most of you would think I'm referring to fruit, most likely. And the reason we do that is, um, in general, you would refer to fruit. The usage of word apple is more often referred to fruit than brand apple, right? Um, so this is very simple statement, but there are more to it. If I were to make another statement where I say I like Apple phone, then your whole perception of what I'm referring to Apple completely changes. Now, from word Apple, you start thinking I'm referring to Apple brand, right? So that's exactly the challenge a computer would face as well. So you can't treat these words as a simple find, a simple search. Um, Based on the words around these statements, around these words, the whole meaning of the word and the whole statement completely changes, right? So, for example, if I add a word I don't like, then the whole meaning changes. For a human, all these would sound very simple. I know I'm making a very simple example here, but solving these kind of problems has taken machine learning models to a very advanced level. We will uh, we will talk about how the space has evolved, like I said earlier, and then we will get into different tasks that we could do using NLP. Okay. So typically, when I say NLP, natural language processing, there are many more tasks than this, but I would like to cover some of these tasks. Given the breadth of the audience, I want to cover what these tasks are, and then also cover a few interesting industrial best practices. So I keep a balance of both beginners and maybe advanced users as well. So starting with NER, named entity recognition, is an example that we just spoke, where Apple as an entity could be of type fruit or could be of type brand, right? So identifying various entities in a statement is NER. And text classification, I think maybe we'll discuss each of these in subsequent slides. So you could do text classification. If you make a statement, whether the person is positive, whether he's negative, that's sentiment analysis. Translation, I think, is pretty obvious to all of us. From English to French, Hindi, Tamil, all these come under translation. Then summarization is very interesting and challenging use case as well, where obviously given we are in academia, I'm sure we will be going through a lot of contents. So how about a AI model giving you a summarized content of each of your chapters or the whole book? That would be really amazing, right? So that's summarization. It's used in places where you want to save time and just look at the summary to get understanding of the whole thing. Then question answering, from the name, again, it's straightforward, where given a paragraph, given maybe even a book, or even the whole internet, right? How do you find answers to a given question? For example, you go to Google, you just search for a question, it brings you an answer, right? That's kind of a question answering problem to some extent, even though it includes search problem as well. Then co-reference resolution is something where if I make a statement, uh, I mean, going by English, if you use his, her, it, all those words refer to some other object, some other nominal statement, right? So finding out those are itself a challenge, and that's considered as a separate NLP task. And the text generation, which is very interesting, where I'm sure some of you using Google might have Gmail or Google might have observed that you type few words, it will start predicting the next word or next few words so that you can select rather than typing. For example, when I use Gmail, I find it very convenient where it kind of gives me what I could respond to the whole email. Or I think even in social media sites like LinkedIn, when you receive a message, you get few suggestions as a reply. Those are good examples of context-based text generation. So with that, let's get into how models have evolved, and then let's come back to these tasks. I think that will make sense. In a typical ML flow, in a machine learning flow, you obviously need data for you to do a machine learning model. So you source the data, you prepare the data for training, and then you extract features that the model can understand. What is of interest? Certain features will kind of go against the model, certain features will help the model. So you kind of identify those features, you build a model. When you say a model, you can maybe equate it to a word algorithm, for example. And then you fine tune it, and then inferencing is kind of prediction. So once you fine tune, you deploy it, and then people predict using the model. And this is the whole typical life cycle or a flow of machine learning development, right? So with the evolution of deep learning, in the schedule I saw 2 sessions on deep learning. So I hope all of you have an understanding of deep learning. If I were to briefly state what it is, it is inspired by human brain. It's inspired from how human brain operates, how our neurons are designed. So it's generally very complex. So you have with so many layers of nodes, and then you kind of design them. There are so many architectures within deep learning. So with advent of deep learning models, the focus or work that needs to be done for feature extraction is pretty much gone. You need to focus on training data, and then you build the model, fine tune, and inference. That's what happened when deep learning got into the industry. But interestingly, there are so many research and money spent on these deep learning models. Academia, many research institutes, and companies like Google, Amazon, Facebook, they kind of release all these models that can be used by us. So with advent of all these latest models, the time spent on building a new algorithm or a new model is pretty much almost not there. The reason is it is very, very time consuming, painstaking activity for you to build such a very large model. Almost if you were to execute a project, if you were to kind of implement a task, some of the things I'm speaking, unless you are a research institute, it won't make any sense because there are thousands of layers, billions of parameters for which it wouldn't make sense. So given that, generally people in the industry who focus on implementing solutions and building application don't spend much time on building models anymore. It's even though a lot of knowledge is required, I would say time is very less spent. So having said that, So that simplifies the whole thing to sourcing data, which data is surplusly available, and preparing and getting the data ready for consumption is mostly engineering work. So we will mostly not talk about data sourcing data. We will focus on how do you get training data, how do you build the data for training, how do you fine tune, and how do you inference. Okay, so we'll primarily focus on that. So when I speak about model evolution, right, this is a graph from one of the internet contents where you can, on the left, you see the number of parameters in millions. And you can see these are some of the model names. So don't worry if you don't understand what these are. So these are like models. Consider these like a library. Okay. So when you write a let's say Java program, Python program, or even a C++, you kind of import a library, right? So you can just treat it like that for your high level understanding, that you just do a import, for example, transformer, and you will get all these libraries required, and then we call something called wait. You load it and then you pretty much do what you want. So for now, just consider these names or models fancy names. So you can see how, and these are, when I say parameters, like consider it like a function where you add so many variables, right? So these are kind of variables in a very complex architecture. The values that you set in these variables kind of decide your outcome overall. So, so you can see they have exponentially increased. So if you, BERT is pretty popular, many of you might have heard. If you relate the size of BERT to a model like T5 or a model like GPT, which I have not even shown here, it's tremendous, right? So that's how the models have evolved. And for you to get a model like this from I think it's going to take a lot of time. So generally, we make use of these models, we fine tune them, and we get what we want. One other important, just for information, is you can see something called Distilbert highlighted here. So because these models are so heavy and complex and time consuming, they took a lot of resource. So there are also lightweight alternates. You can see the weights are pretty low, like 66, right? It's even smaller than Elmo. But these models are pretty light, but they give you, for example, in case of Distilbert, it's 70% smaller than BERT, but it can give you over 90%, close to 90% of BERT's accuracy. Just for your info, you don't have to worry about. You don't have to worry about it if you don't get it. So this is how models have evolved. Given the model evolution, just to state another aspect of how good these models are, right? This is a leaderboard for a data sets called SQUAD. So SQUAD is a question answering data set where for training a model, usually you need what's the data and what is the expected answer. We call it label. So so for this data set, if you give the content to the human and ask them question and find answers from them, the human accuracy level is close to 90%, let's say, less than 90%, right? But the industry has developed so many models, and almost top 20 models have exceeded human performance. What I mean by that is, if you or I, or generally as humans, if we were given a content, top 20 models as of today, probably this data is old, maybe months old, um, are expected to do better than humans, which is really amazing, right? Most of us think, I receive an email, how can a machine understand and kind of do like what I do? But the reality is actually different. The models are so good, they're amazing that they have started outperforming. We have to put them together. They have not learned to put themselves together in an overall problem statement. So still, the value for human is a lot. But I'm just giving you a perspective that given a task, if you were to focus on only question answering, um, models can beat tests just like that, and many other tasks. So with that, I will now and then revisit this flow. You understand the overall flow and what section I'm focusing on. Um, so, ma'am, should I pause and take questions now and then, or take questions towards the end?
So anything is fine.
Okay, maybe I'll take one or two questions.
Sure, sir, sure.
Yeah. Any of you have any questions, please unmute and ask.
Participants, if you have any queries, you can ask Sylvester sir, or you can post the question in the chat box also.
Yes. Okay. Interest of time, I'll move on. Uh, Please feel free to stop me if you have any questions. Okay. So, getting to the training data, right? Like I spoke earlier, um, you these are supervised learning. I am sure I saw a session on supervised and unsupervised learning. To briefly talk about it, supervised learning is kind of a training where you tell the model, hey, you see this text, this is what it is. You are giving an answer. It's like you are teaching a student or you are teaching a baby, where I think taking vision example is easier. You show an elephant picture and then you show it is elephant, right? You show it is a giraffe and then tell the baby it is giraffe. So it is similar to that. So where you kind of give what is the content and what is the expected answer, you expect the model to speak. In our example, the baby to speak. Obviously, like I always tell my team members, treat models like baby, in the sense of what it knows, right? So when you ask a baby first few times, it's going to get mixed up. It's going to give you, the baby is going to give you incorrect answers. But as it sees often, as you keep telling it, it's going to learn, right? That's pretty much the whole funda of deep learning. To give you another example, let's say you are learning a new game. Let's say you are learning tennis or cricket. Maybe let's take cricket, given most of us in India is big fan, right? So when you are playing a shot, sometime you may hit it and you may miss it, you may be out, or you may give a catch. So if you are to trying to hit a six, so you will play many balls, you will adjust your angle, you will adjust your power. There are so many dynamics, the way you handle the bat, right? So like that, all these dynamics of your bat angle, the speed at which you swing, all those are kind of parameters. So when I earlier told you million parameters, GPT-3 has like billion parameters. All those are so many aspects that will decide what is the outcome. So having said that, so in a supervised learning, like you show this is the picture and this is the name. In a NLP world, you have to give the sentence or the paragraph and say what is expected. In our earlier example, if I make a statement, I like apple, I expect the model to tell me it is fruit, assuming that is what I want. And when I say I like Apple phone, it's definitely I want the Apple to be identified as a brand, not as a fruit, right? So that is how I will prepare these training data. So as you can see, I'm just talking about one or two statements. If you were to, for deep learning models, usually you need so many data. I would say lakhs and lakhs of data for a complex model, but it is generally painstaking. So there are tools out there. Um, in this case, I'm referring to a tool called Label Studio, which enables you to annotate and export the annotation. When what annotation is more of highlighting. I'll show the next slide just to give you what is annotation. So if I were to refer this 4.4 million as money, The tool kind of gives you option to highlight it, and then you can say it is money. And I can refer Google as an organization. So uh, you kind of provide all these inputs. You give a paragraph, you say, hey model, I want you to identify this 4.4 million as money, and Google as a organization, Apple as an organization. You kind of give this data, and this data, as you annotate, you can save it and then export it to a format suitable for models. So you feed it to the model, and model will start learning. Obviously, the first time it may not understand Apple. It may detect Google and Amazon, which is less ambiguous and confusing. Whereas Apple, it may say fruit. As you provide more data, it will try to understand, okay, when I have words like Siri, when I have words like maybe hardware, when I have words like phone, laptop, then the word Apple is not fruit, it is organization. So it will eventually, that's called context-based learning or context-aware. There is a very popular paper called All You Need Is Attention. I'm sure as faculties, you will keep saying your students pay attention. Likewise, the NLP model, all it has to do is pay attention to the words around it, so it can understand the context and decide what to do, right? So with that, um, so what we generally do is when we were to annotate, there is a concept called active learning, which is what I want all of you to be aware. Um, so active learning is a concept where um, you you have a model, you annotate few records, and then let's say you have 1,000 records. Just to give you an example, um, you will not annotate all 1,000 records because it's going to take a lot of time, right? And with pre-trained models already available, you don't have to start from scratch, right? You can start with the pre-trained model that already exists. For a year, there are many models. Let's say you are taking a model, for example, Robota. Robota is one of a near model. So you take Robota, and then you kind of label only few records, and then through this annotation tool, you export it, and then let's say instead of Robota will already sell, and it, I mean, already predict organization money, all that. Let's say you want to detect, let's say you are building a e-commerce search solution, and you want to identify the various products in the e-commerce platform. Think of word like our Indian terminologies, right? Kurta, yeah, which may not be trained through other nations, but it could be domestic and you may have to train it. Going by that example, then you annotate those words as what it means, and then you kind of feed it to the model, right? So first time, like I said, it may not detect apple as or but as a fruit. So then you could use the tool both as an annotation tool as well as a review tool. What I mean by review tool is you can, when the model makes a prediction, you can import the predictions to the tool and you can kind of look at it. So in this case, the apple will be annotated by mistake, let's say as fruit. You will delete it and then you will annotate or. So as models keep making mistakes, you will review it periodically, correct the mistakes, and then it will eventually learn. And generally we call it iterations, all that. So we do so many iterations. We keep, first time it may do like 10%, then you do it will do 20, 30. Eventually we kind of target at least 80, 90% in most of our projects. So another example to the context given the faculty domain, right? So if you are correcting a paper of a student, you would manually look at it, and then you will say, hey, you didn't answer this question correctly. You filled this blank incorrectly, and so on, right? So treat that as your review process for the model. So model will predict. It may fill the blanks, it may choose the best answer. All these are types of tasks, right? Or the student may summarize it. All that you kind of review and say, hey student, this is not right. So and obviously students will learn and they will start doing better. It's exactly uh, how these things operate. Okay, so this is very, very fundamental. Without this step, it is very difficult to get good accuracy and really productionize a great application. Okay, so that is why I want to ensure all of us understand uh, what is annotation, what is a review tool, how you could use it. And the good part is, like I said, you take a pre-trained model. Out of 1,000, you annotate only few tens, like maybe 50, 100, and then you immediately teach the model just from the 10% of the data. Okay, so from the 10%, the model will show some improvement. Then you annotate another 50 or another 100. By the time you cover 200, 300, what we have seen is the models are so great that they start giving you 70, 80% accuracy or even better. Obviously, it depends on the problem statement, but this is what is called as active learning. And we have also observed many deep learning projects fail or grossly overestimated and then takes a lot of time because people don't use active learning very well. I have come across customers who think they have to annotate like thousands of images and it's like a 4 or 5 months project. But that's not the case. With, like we spoke earlier, the model evolution and these tools in place, you can annotate incrementally and then get to a greater accuracy very faster compared to just manual annotation. I want one of this to be a very important key takeaway from this session, because we don't really spend much time on model building or even fine tuning. Like usually there is a stat, right? 80% of the time by a data scientist is spent on data cleansing, preparation, all that. Pretty much we spend most of our time preparing training data, correcting those, and then fine tuning the model, so we get better accuracy. So that's key takeaway: active learning and how you use these annotation tools to build a model faster. Okay. Any questions? Okay.
Sir, what do you mean by fine tuning?
Sorry, come again.
What do you mean by fine tuning?
Sure, I'll definitely get there. I'm going to cover that in subsequent slide. Is that okay?
Okay.
Any questions on topics that we discussed so far? Model evolution, training data and stuff, or annotation tool, active learning, anything? Okay, I'll take that as a no. We'll move on. The next part I'm going to focus is on um, model building, which even though, excuse me, even though we don't spend time much on model building, it is important to be aware that what models exist, what is happening in the model space, because that's when you will choose the right model, right? So even though it is, I'm underplaying the model, it is very important to keep track of how these models are evolving, which model to use. There is no straight answer. You have to try maybe 4 or 5 models based on your data, based on hyperparameters and a lot of other criteria. One of these models will do better. So it is very important. I'm definitely not underplaying it, but as a team during the project execution, you will spend relatively lesser time. That is all I'm trying to say. So given this is an NLP session, it would be a sin if I don't talk about word embedding. So I'll briefly talk about how embeddings have evolved. I know there are so many words. I'll not get into any of these specific details because if you are keen to learn this, there are a lot of materials out there. You can learn them. And like I said, we don't spend much time on deciding these. Your model decides the embedding. So, but just to briefly talk about it, Given a word, the models initially the embedding was not that intelligent. There are popular examples like male is to female, then king is to queen. What I mean is, if a model knows that when I say male, the opposite is female, then when I say king, it may not know that queen is opposite, but it can relate. Okay, it's called a distance in a embedding vector. So it will kind of calculate it based on cosine similarity. So those things started coming out only during glow related embedding. Before that, it was mostly word count based logic and so on. So the embedding started evolving very nice with fast tests from Facebook, blazing text from Amazon, and BERT is pretty popular, and these days we mostly use BERT embedding. BERT embedding is very nice, and it can take care of your unknown words pretty smart. The key thing to understand about embedding is when I say a word, apple, um, you have to understand there are different dimensions to that word. The word apple, from a dimension of fruits and vegetables, it has a relevance, right? And when I say again word apple, from an electronics or a company point of view, it has a similarity. So you kind of see these embedding as your kind of a vector, like a data store, where there are so many dimensions, like consider like category in your e-commerce, like fruits, vegetables, then electronics, household. I'm just trying to simplify it. Um, so under these dimensions, how a word apple is related to. So that is what end of the day they try to solve in embedding. This is foundation to your model. With that we will move on. So that is word embedding. And in terms of model evolution, like I said again, attention was a major change in how these models perform. You might have heard of terms like RNN, LSTM, bi-LSTM, attention model, which I briefly spoke about, then transformer architecture and so on. All I want you to understand is architecture, like think of architectures like your cars maybe, or any electronic. When you bought a laptop, initial laptop might have been with lesser configuration. It's not exactly laptop, maybe I'm underplaying it, but like you add more features, it becomes more complex and it can do so many things, right? It's similar to that. So these are your architectures where you have many hidden layers, how they are connected between these layers, how the weights are organized, how data from one part is moved to the another. There are so many things to it. To keep it simple, as long as you understand these were the popular architectures, um, I think we are good for now. So BERT is probably one of the most revolutionizing model. And based on BERT, many models came out. If you recollect the graph we saw earlier, so many models came after BERT, and definitely attention, transformer, and BERT is foundation for you to start. If you were to start learning today NLP now, even though it's good to understand what is RNN and LSTM, because these architectures were developed on top of these fundamentals. It's not that RNN was useless or LSTM was useless. It's like an evolution, like a human evolution or various evolution. They evolved. So for you to understand transformer, maybe RNN knowledge and LSTM knowledge is required. But if you don't want to get into understanding these architectures, um, that is definitely good. Still, you can build a great application. Obviously, you will be limited when you have to get into details. But if you were to just know something good and greatest, transformers and BERT is a good start. Okay. So that's on how models, architectures, embeddings have evolved. So that covers the build model. Let me get to fine tune, which we had a question. What is fine tuning? There are two parts to it. So one is if you take transformer as an architecture, right, which I spoke a couple of slides back, it was trained on a task, something called masked language modeling. We call it MLM. Okay, it's definitely not multi-level marketing. It's masked language modeling, where you have say it in layman terms, consider them like a filling the blanks. We have been doing it from school days, where they would make a statement and you have to fill a blank, right? For example, Dash is the president of India, for example. Then the model, based on learning from different content, will try to fill who is the president of India. Okay, so and it was also trained on next word prediction. So yeah, if I have a word, if I have a statement, what is most likely my next statement? So it was trained on these two tasks. Why am I explaining this is, remember we spoke about various task types. We spoke about NER, question answering, classification. These models were not actually trained on these for these tasks. Okay, all they know to do is MLM. They can fill in blanks, they can predict next statement. But the interesting part was you can fine tune this model. You can take a BERT model and then fine tune it to do NER, named entity recognition. You can fine tune it to do question answering. You can fine tune it to do classification. And again, you don't have to write code for fine tuning all this. Pretty much all these are already standard. So you get the fine tuning code as well. Okay. So after that, beyond fine tuning them to NER and Q&A, what I also mean by fine tuning is the model might have seen XYZ data, right? Going by our, let's say, college example, there will be many subjects. Let's take maybe physics, chemistry, or in different colleges. Let's take that as an example. If the model was trained on chemistry-related content, even though it can understand how the statements are formed, how to understand maybe X chemical versus Y chemical, all that. If you try to ask a physics question, or if you ask to identify entities of a physics, it may not be able to do, because like humans, models also learn as they see content. It's like asking a guy who is from some other specialty, right? So if you were to educate your model to learn physics, you have to feed physics content to it. And then the model, while you feed the physics content, the model will kind of realign its weights, and then kind of learn what you are feeding. And then it will kind of start doing better. As we discussed earlier, you should still use the active learning methodology I spoke earlier. Then the now model will understand physics, and then it will start answering, and it will start doing all these tasks. So that's more about fine tuning. So why this is very good and important is the effort of building exclusive models for NER Q&A is very expensive, time consuming, and all that. And with BERT and MLM task, all those complexities, dynamics changed, and we are able to build great models just from a base model that's trained on MLM. So that kind of conveys what fine tuning is. Did that answer your question, or do you have further questions? Whoever asked that.
Sir, one of the participant has posted in the chat box, sir, I would like to know review tools for Indian languages.
Okay, so I think there is nothing specific like Indian language. Let me move to the slide and come back to the slide. So if you think about it, right, let's say you are doing a translation task, and all you need to do is this tool should support the Unicode that it can understand Indian language. Unfortunately, I have not experimented this tool with other languages. Maybe I'll share my email towards the end. I should have shared it in the initial slides. I'll ping it in the chat. You can please reach out to me. I'll definitely find those details and I'll share it with you. I think the tool per se is capable of doing what you expect. It's matter of supporting Unicode, and these are open source tools which you can kind of enhance, and Unicode support is, in my point of view, is not that difficult. You can enhance these tools even to support it, if even if they don't. In fact, we have done many customization in this open source tool to suit our need, and that's how you could use a review tool.
Thank you, sir.
Yeah. On fine tuning, I hope I answered the earlier question. If not answered, please uh, you can stop
Sir,
me.
then what is hyperparameter actually?
Okay, so hyperparameter is like the cricket example we spoke earlier, right? If you are trying to hit a six, what are the things you need to take care to achieve it? You need to increase your bat speed, you need to increase your maybe angle, elevation, and so on, right? So each of those dynamics parameters will affect your output of hitting the six, right? It is exactly the same. So I'm not sure if you attended earlier sessions on deep learning. Deep learning has a architecture like layered one after another, right? You have an input layer, then so many hidden layers. With attention, there are so many things into it. And each node, so if you look at a typical deep learning architecture, they call nodes. It will be circular, and it will take some input and it will return something. That circle contains active functions, and we call that piece. The piece can better perform based on how you tune it. Or good, another example could be to you drive a bike and you expect your mileage to be better.
Sir, 1 minute. That all these neurons have weights. There may be initial bias and there is activation function. Okay, sir.
That is correct. Yeah, yeah. That's correct.
Then which one among these is called hyperparameter, or all these things are called hyperparameter?
So no,
we actually what we do, we learn the weights. This is our task actually. From the data, we learn the machine learn the weights.
Okay, okay.
That I understand. That I may be wrong, but what I understand that we have to learn the weights. Okay. That all those weights that will be what for this context, what should be that. That is the training part, that determining the weights.
Right. So just to add on to, apart from these parameters, right, there are also techniques like sometimes the model may overfit. You may do dropout techniques, regularization. Those also will come under hyperparameter tuning. My suggestion is maybe I'll share again my email or my LinkedIn and other details. You can reach out to me. I'll definitely connect with you and we can discuss.
Okay, thank you.
At high level, as long as you understand there are so many dynamics to the model, and tuning it to do better is hyperparameter tuning. And there are also different techniques like dropouts, regularization, which I briefly mentioned. That is all is hyperparameter tuning. Okay. Why this is important is, like I said, a single model, there is nothing like for this task, this is best. There is nothing defined like that. So based on data and other dynamics, you will get results in varied models. So in order to do that, we do something called AutoML or autopilot, where you take a list of models. Each model have different hyperparameters. So you can think of them like a characteristics of the model, and you kind of feed a range For example, if you're building a deep learning architecture, number of hidden layers itself is a hyperparameter, right? So
Okay,
if
sir.
you get to very low level, so you can kind of configure all that. You can try various combination of hidden layers, number of nodes in the layer. All these are hyperparameters.
Okay, now,
I
sir, I
hope
can
that answers
understand.
your question.
Thank you, sir.
Yeah. Welcome. Any other questions? Just checking the time. Okay, let's move on then. I think we discussed fine tuning. Let's get to different tasks. So we spoke about named entity recognition already. I think most of you would be already familiar. It's a subtask of information extraction. Information extraction involves many ways of extracting it. Named entity recognition is pretty popular. So it's identifying whether in a given statement, whether the word is a person, whether it is a location, whether it is a brand. If you think of a e-commerce scenario, right? If a person searches for a product like, let's say, 32 GB, 1 TB Windows laptop. So you have to interpret this query, for example, as 16 GB. The model will kind of interpret or predict that, okay, 16 GB, I think is RAM here, 1 TB is hard drive here, and Windows is operating system, and then laptop is a category, whatever level category is. If you're able to interpret a query like that, you will be able to filter the products much better and then give the users a better result, right? This is one example of using NER in search scenario where e-commerce search. You can extract contents of your interest. For example, we did a biomedical project where given the COVID situation, right? So we were trying to extract various diseases, drugs, how the treatment behaved for the drugs. So you can do content extraction and look for a specific entities that you're looking for. And then based on what kind of entities or content the user is interested, you can also identify them and recommend contents accordingly. Even though recommendation itself is a different problem statement and thing to discuss, it could enable better recommendation. Okay, then you have classification, which many of you might have heard. Text classification is trying to classify a string or a paragraph or a very large content into a bucket. Sentiment analysis is very popular text classification subtask, where if I make a statement, I like Apple products, then the like is a positive statement, right? So if you divide your sentiment into positive, neutral, and negative, I like will become a positive statement, I don't like will become a negative statement. Or in the other example that we just put, if I am requesting for a 16 GB RAM Windows laptop, the laptop, because of the word, the whole query could be categorized as a level 1, level 2 category, where level 1 could be your electronics category, level 2 could be your computer and laptop category, and so on, right? So you get an idea of how categories also can help in understanding different content. And in this slide, I have given an example of classifying article, where an article can be classified as a technology article, sports article, and so on. I can also help you detect intent of the user. Intent is very well used in stuff like Alexa, your chatbot related solutioning. And spam detection is very popular example for text classification. Then next thing is translation. I think this doesn't need much of a introduction or explanation. As even in India, we speak so many languages. Even if we travel to another state, you may not know what they speak, right? So it is very useful where you kind of the machine, if it can interpret what somebody speaks. Already Google has, or there are many products out there which can translate language for you. In fact, this is something I took from Google, where it is able to give you the translation of what I mean. So it's not only pure text. If you travel or you see an image, you see something written there, you point your camera from the image, the text is first interpreted, it's identified that the image has a text, and then the text is translated and then fed. So it's a chain of operation, but translation could be used in document translation, email, and any domain specific translation as well. It need not be only language, it could be domain related content as well. Then summarization, we kind of spoke briefly. There are so many contents with digital, everything getting digitized, and so many articles, news, and so on. It's hard for you to catch up on all the content, right? So it can kind of, if your model can kind of summarize the important content. Think of students or even like faculties where if AI can help you kind of summarize new books, new articles for your exams or for your daily activity. It's just amazing, right? So that's this task. It can be used for legal documents. We have done some work where legal documents are very lengthy, so many contents, so many clauses. So for a team to review all that and ensure they don't end up paying for any litigation is so serious. So we have built models where given lengthy legal documents, it can highlight high risk statements and items. It can, if you train a model, it can highlight which might be of a surprise to you and so on. So I'm sure many of us would have applied for home loan and so many things where you had to go through so many pages of signatures and stuff, right? So summarizing the risks in those agreements would be just amazing, right? So we could do that. I spoke about books and literature summarization. We do so many meetings on a daily basis. I'm sure many of you will attend meetings. How about a model listening to your conversation and then summarizing it for you, like action items and minutes? These are some of the use cases this could be used. Obviously, help desk and customer support as well. Um, then question answering is pretty obvious. Given a comprehension or a content and a question, the question answering model will try to find answer in the content. This could be used for information retrieval from a knowledge base. As a company or as a organization or institute, I'm sure you will have a lot of policies, guidelines. If somebody were to look for certain guidelines, rather than going to find where the document is and within the document trying to locate what the answer is, they can kind of feed a query, and if you have a nice indexed content, the model can kind of give you the relevant answers. And content based search also can be taken care through question answering tasks. And co-referencing, I think I briefly gave an example earlier. So if I make a statement, Daniel lost his phone, but Vijay found it and returned it to him. You can see, for humans, you might think it is easy, but for machine, it's a difficult one. What is co-referencing here? So you see Daniel, right? So lost, his. What is his here? What is it referring to? It is referring to Daniel. You can see that his refers to Daniel, right? His phone, and Vijay found it. What is it? It refers to phone, right? And returned it. What is again it? It means this, right? Which is phone again here, and him finally. There are two people in the conversation. I'm referring to Daniel, I'm referring to Vijay. So who is him? And the model can find that it is Daniel, not Vijay. So if you think about it, it's amazing. It's a nice visualization of the model output. But even humans can easily go wrong in a complex statement, lengthier statement, and so on. Co-referencing is applied in many other tasks we spoke earlier, so I didn't explicitly state some examples. But yeah, that's co-referencing. With that, maybe I'll take a quick check any questions. If not, I'll move to solutioning preference. Okay, I'll take that as a no. I understand obviously these are very straightforward NLP tasks. So having said that, so part of Center of Excellence, we have guidelines on how to approach a problem, or what should be your solutioning. What is our guideline is, so before I talk about guideline, let me tell you what these are. For a given machine learning problem, you have different solutions out there. For example, some of you might be familiar with REST APIs. If not, you can assume it is a request and a response, as simple as that. So many cloud providers and third-party providers have already created many models, and then they have exposed it as a simple REST API call or even a SDK. Okay, so for example, we spoke about many tasks, right, NER, question answering, and so on. Those models are deployed and always available for you through these cloud providers. So if you were to find an entity, do a question answering or any of it, if it is a simple problem statement, or if be it simple or complex, I think is secondary. As long as your problem statement can be addressed through these providers, these pre-existing services, our suggestion is to use them, because you don't have to reinvent the wheel. They are already out there. All you have to do is just go and integrate it with your application. For example, if you were to find entities, and if those models that are provided by any of these providers can understand what is Apple as an organization, can understand or can do translation, then why do you want to train something by yourself, right? So that's our first step of order of preference and simplicity. So we suggest, if you were to build, one of the things I like about this offering is there are many people out there who has great ideas, right? They could be entrepreneurs, they could be a student or anybody who wants to build something, solve a problem, right? But they may not be good at AI. And I believe you need not be good at AI. As long as you break down the problem and you can integrate with these kind of services, you might be able to solve many problems out there. And the cost is very cheap. Almost, I think, for 1 million requests, for 1 million predictions, you pay like 20 cents, which is, I believe, like less than 10, 20 rupees, right? So that's our first order of preference. And next preference would be to use libraries. I have added only NLP related libraries here. We could use something like Hugging Face or Spacey. I have few slides on Hugging Face, and I'm doing another session today afternoon where I'll be running many demos on Hugging Face, and I'll be showing each of these tasks. I'll run a demo to show how NER can be used, how classification can be used using Hugging Face. Maybe it's a marketing kind of a content where, I mean, please join if you have time for the other session. So I will give some good insights on how to use Hugging Face. So that's your next preference if APIs don't solve your problem. Then next thing is a framework like TensorFlow or PyTorch. Some of you familiar with machine learning, I'm sure would have heard about TensorFlow, PyTorch. Hugging Face, what I have seen is not many people know, but if you know, that's great. And if all these, when I say use it, I'm only referring to pre-trained models, right? If you think the existing models for some reason don't solve your problem, then you can definitely go for existing models. There is something called transfer learning, where you don't start from scratch. All the models out there are implemented using transfer learning. What is transfer learning? You take a model, what it has learned with its weights, like somebody said, bias, all that thing, and then you add few things on top of it, train it again, and then you kind of make the model even better. So finally, we would suggest, or see, even fine tuning kind of uses transfer learning to some extent, but Point is, go for custom models only as a last display point, which we have not come across much, to be honest. Okay, so that's the order of preference we suggest. So that I believe will help you to implement solutions faster. Then I spoke about REST API. This is one of screen grab from Azure, where if you, this is UI, they have a website. You can go there and if you see this content, we went to Pontoso Steakhouse, for example, located at Midtown NYC, right? So the model gives you various content from this. I have just scrolled and then grabbed the entities related because it is easy to understand. So you can see under entities section, it has an array of entities. You can see under category location, it has found this teak house. It's like our, let's say, Saranabhavan, Sangeeta, whatever, where you can say that's a location. Or if the model is trained well, it can even say that it's a restaurant. And here, New York City is detected as location and so on, right? So I'm just giving you a glimpse. And if you scroll up and go these sites, you will see question answering, sentiment, and all those contents. So all you have to do is just feed the text. It will give you what you're expecting. As long as you are good with this output and the accuracy, I think this is a great start for many projects. If you are a beginner or if you are building an application and want to use your AI, definitely please check this out. Then I spoke about Hugging Face. Hugging Face is a transformer. I mean, they have more than transformers, but they have it's a Python library where they have model repository, they have data sets, they have abstracted the complexity of NLP to a very, very large extent. Whatever we used to do, like maybe tense is probably understatement. I would write like 40, 50 lines or more to complete a NER task. I think with NLP, you could do in like with Hugging Face, you could do in like in 4, 5 lines. It's pretty amazing, and they are doing really great. And they are adding more models, more tasks, and anybody who wants to work on NLP, I would strongly suggest start with Hugging Face. It's a great library. If API doesn't solve your problem, REST APIs, definitely you should check out Hugging Face as the next thing. To show you an idea of what you could do with Hugging Face, right? If you want to do an NER, right? All you have to do is just import it. This is the import statement. It has pipelines. You can customize the pipeline. If you just initialize a pipeline, it comes with default pipelines. So here, by giving a word NER, I'm saying what kind of task I'm going to do, what type of pipeline I need. So here the pipeline is NER pipeline. So whatever needs to be done for NER pipeline gets initialized, and then it's assigned to this object. And then if I were to identify NER for this line, all I have to do is just do a print, call this NLP object. Inside that, I pass the sentence I want to detect the NER. And you can look at the output. Even though some of these comes with the BERT embedding output, right? But you can see Hugging Face is detected as an organization. IORG stands for organization. You can see New York City. Behind the scene, each word is split and then they are analyzed. Even though they are broken, New York City, it understands the sequence of the word, and then it kind of identifies that as a one whole thing. You can see it is identified as a location, and then and so on. So that's NER. And classification, if you were to do classification using Hugging Face, all you have to do is from transformer import pipeline, you give a pipeline as sentiment analysis, and then you pass the word. That's it. Hardly 2 to 3 lines, right? I can even convert this to probably a 1 line accept input, or even I can just write this in 1 line, right? So pipeline, you give a task type, and then you pass I hate or love, and then it can give you what's the sentiment. Then another example for question answering, where you import, you define what pipeline, what task, and then you kind of print NLP question equal. Because here for question answering, you need two things, right? You need the context or the content, and then you need the question what you want to ask. So here the NLP takes two arguments. It takes the context, which is initialized here, and then you take the question, and then you kind of get the answer that you're looking for. So if you look at it, it gives you a confidence score. It tells you what is the start and end position where the answer is in this passage, and then it gives you the answer also. You can directly use this, or you can fine tune this. So that's about question answering. I think I have 15 minutes. I'll try to spend 5 minutes on model development, life cycle, and ML ops, and then we will close. So before I move to MDLC, any questions? Okay, I'll take the decimal. Either I'm making sense or I'm not making sense at all. I hope I'm adding some value to your time. So let's see. Fine. So on model development lifecycle, I'm sure many of us might have heard about software development lifecycle, SDLC, and for AI or data science, we use MDLC. If you think about it, it's kind of pretty straightforward, right? So you have raw data, you prepare the data, and then you train the data, you prepare the training data, and then you train the model. The model training would come out as a model artifact. Like I said earlier, you will try many models, many hyperparameters. So you have to define an evaluation criteria, evaluation metric for you to decide which of these models and which of this combination of hyperparameters and etc. Gives you the best output, right? So that based on the evaluation metrics, you will kind of create a model. When I say create a model, we also maintain versions of model. So you kind of create a new model version in your model repository, and then you can deploy it. Once the model is deployed, you can inference, and client can consume it, right? So another important thing to understand is change is the only thing that always doesn't change, right? So everything changes. So the change also will affect the model. So it is important to monitor your model constantly so that you can analyze how your model is performing over a period of time. So to give you an example, you built a model for house pricing. You define certain criterias, and then based on the features, the model predicted XYZ price and so on. The government might have launched a project near the area, or there could be change in the locality or any of the features that may affect the price prediction, right? So you have to constantly understand how your model is performing, and then if you need to add new features and so on, you need to accordingly tune your model. So model monitoring kind of helps you monitor um, the accuracy while users predict, and also it helps you monitor data drift. So once you start monitoring the data drift, and based on some threshold, you can always trigger retraining of the model, retrain, and then launch a new version. So that's very high level. I mean, I'm speaking about all this because I don't want to just talk about NLP, because what if you have a model? What do you do with it now? I want to ensure all of you kind of understand this whole cycle and adopt the best, right? So talking about the best, there are so many hurdles and pain that a data scientist goes through to productionize this model. You have to think of so many things. You have to manage versions. You have to kind of ensure all the machines that you deploy or train has required libraries. You will often get into version related issues when you set up these machines. So that is where Dockers, Kubernetes, all these things really help you orchestrate this whole thing with the CI/CD pipeline, all that. So briefly stating what is MLOps. MLOps is, I'm sure some of you might have heard about DevOps. So it's your DevOps for machine learning. It enables you to kind of streamline the whole pipeline, starting with source code, then your build pipeline, containers for your version control, not only source but for model as well. It kinds of helps you manage your distributed training. For example, if you have used cloud, I'll talk about spot instance, all that in next slide. So it can enable you to cost effectively train and pretty quickly train models. And then it can also help you monitor and all those things what I spoke earlier. So it is DevOps for machine learning, to keep it simple. That's what it does. And this is one of the key asks from many of the customers, and we have been doing it for a few customers. And we strongly insist anybody working on deep learning or machine learning to adopt MLOps. So what are the advantages of MLOps? Starting with data, right? Data, like I said, will keep changing. You will definitely train your model many times. So it helps you version your data, starting with that. When it comes to training, which is your primary activity, there are so many things you need to take care. Typically, olden days, when a scientist does various experiments and trials, they kind of keep track manually through Excel, and it was a very painful process. But these days, these things come with various experiments and trials capabilities. It can keep a track of it, help you sort by your evaluation metrics. Distributed training is another very important area. Many of these deep learning models takes, you won't believe, not hours, generally weeks to really get done for a larger data. But if you were to reduce the uh, time from weeks to minutes or hours, you need to definitely do a distributed training. And with so many hours and part of data involved, cost and time both are factors, right? So that is where spot instance can help. Spot instance is type of instance in cloud where, see, these cloud providers have many machines, right? So their utilization will not be always or mostly 100. So they will give the remaining machines, unused machines, to with a cheaper cost. Usually they are 70% cheaper, 70 to 90% cheaper. Uh, that's the good part. But the bad part is they can take away the machine from you in few minutes. They'll give you a warning or alert, and then they can take away the machine when it's needed. So you kind of have to swap between the machines if you do like weeks or hours of training. And all those complexities are taken care through something called checkpointing, where before you lose a machine, you store the processing you done store for, and then when you get a new machine, you kind of resume from there. So that is where, so this combination of distributed training, spot instance, checkpointing, all these will enable you to save a lot of time and cost, both. We spoke about hyperparameter tuning. There is also this whole thing about debugging, explainability. These are the things, if you're interested, you may have to consider, and these tools have good support for it. Debugging, all those, not exactly MLOps related, but I'm just running through some of the things you could consider. And then model versioning, we spoke about. As you release various models, you can keep different versions of it. And when you deploy them, you can deploy like a A/B. Generally, we say it as A/B testing, where you can deploy two versions in parallel, and you can divide your traffic into 30-30. Like, sorry, 70-30, 80-20, 50-50, whatever. And then when the request comes, it will go to both models. This is like load balancing your application. You can, A/B testing is done on applications as well. Then you kind of see which model performs better and then decide what to do with it. Then finally, we spoke about model monitoring and data drift already. So with that, I think pretty much I'm done with what I want to share with you today. And I'll happy to take questions, and anything you want to discuss, feedbacks, I'll be happy to take those. Thank you so much for your time. Thanks for listening patiently and then spending time open to the questions.
Participants, if you have any questions, you can ask sir. Okay, I request all the participants to turn on the cameras so that we can have a photo here. Can you please turn on the cameras? Thank you. Now let's have a break for 45 minutes and we'll be having next session that will be the continuation of your session 12, the natural language processing. And thank you, sir. Thank you so much.
Yeah, once again, thank you everyone for spending your time with me. Thank you. Have a
It's a
great day.
pleasure. Thank you, sir.